Okay, so we're going to start doing acid-base calculations. The important thing to know as we start this is that we know there is a pH scale, but there is also a pOH scale. And so we'll get into exactly what those are a little bit later, but for now just know that that there are two scales. And so let me draw out, we'll put pH up here on the top half of this line, and we'll put pOH below that line. So we already know that a pH of 7 is neutral, and there is a corresponding pOH that is also 7. But then here's where it changes. If the pH is 0, the pOH is 14. And if the pH is 14, then the pOH is 7. And so you can see that the pH scale and the pOH scale are effectively flipped from each other. And so if we fill the scale in on the pH side, we'll go 0 through 14. The pOH scale would go 14 to 0. And so the pH is really what the pH is measuring is the amount of hydrogen ions in the solution. And the pOH is measuring the amount of hydroxide ions in the solution. And you already learned that there's a relationship between the H concentration and the OH concentration, where if the H concentration is equal to the OH concentration, then that is neutral. And we know that neutral has a pH of 7. Well, it also has a pOH of 7. And then if the H concentration is greater than the OH concentration, well, that tells you that the solution is acidic. And the pH would be somewhere between 0 and 7. Well, the pOH would be between 7 and 14. So they're basically just opposites of each other. And so an important thing that you can recognize from this scale is that we can actually create a formula from it, or there is a formula that comes from it. And if you look at the pH at any given point on the line, and if you add to that the pOH at the same point, so for example, if we choose this point right here, the pH plus the pOH is equal to 14. If we choose this point right here, the pH plus the pOH is equal to 14. Any point on the pH-pOH scale, because they're really the same thing, if you add them together, pH plus pOH, then you get 14. Okay, and that is your first acid-base calculation formula that you'll need to know. pH plus pOH is equal to 14. Now, what is pH? Well, the formula for pH, it is the negative logarithm of the hydrogen ion concentration. Okay. If the pH is the negative log of the hydrogen ion concentration, well, we can also have a pOH formula, which would be equal to the negative logarithm of the hydroxide ion concentration. So if we know the concentration of OH, we can find the pOH. And if we know the pOH, we can find the pH because we just subtract from 14, right? Or if we know the H concentration, we can find the pH. And if we know the pH, we can find the pOH. And if we know the pH or the pOH, we know whether it's acidic or basic or neutral. All right, so example, what is the pH of a solution that has a hydrogen ion concentration of 4.5 times 10 to the 4th molar? Remember from last unit that molar, we're talking about molarity, molar is concentration, okay? And so if you use the pH formula, because we're looking for pH, and we have H, okay, so we have this, and we're looking for that, then we're good. So pH equals negative log of the H concentration. All you do is stick that number here. So negative log of 4.5 times 10 to the negative 4th punch that into your calculator, and you're going to get 3.35 is what the pH is. Okay. You'll actually get a negative answer when you do the log of 4.5 times negative 4, but then you have a negative here, so the negative of a negative is a positive. And so we get 3.35. Now, okay, so example 2. What is the pOH of a 2.5 molar solution of sodium hydroxide? So at first glance here, you might think, well, they don't give me the concentration of OH, but all you got to do is just look at what you have. You have sodium hydroxide, which is a strong base, which means that 100% of it is going to break apart into sodium ions and hydroxide ions. And if you have 2.5 molar NaOH, so that means you're going to get 2.5. Okay, so we have 2.5 molar OH. So pOH equals negative log of OH. And so plug negative log of the OH concentration is 2.5 molar. Remember, molar is concentration. So 2.5 goes there. The log of or this negative just comes down. The log of 2.5 is 0.398. And since there is no negative out of the log of 2.5, then the pOH is negative 3.98. Okay, one last equation is going to be the self-ionization of water equation, which is Kw is equal to the hydrogen ion concentration times the hydroxide ion concentration. And so this is Kw is called the self-ionization constant of water. Self-ionization constant of water. K is an often used symbol for constants in chemistry. The little W there is for water. Okay, we talked about this in class a little bit, that in water, a small portion of water can dissociate to form hydrogen ions and hydroxide ions. And we get this back and forth where some goes to this and some comes back. We get this small amount of water that will do that, and that is called the self-ionization. Water ionizes itself. It will turn into ions. The amount that this occurs is pretty small. The concentration is going to be 1.0 times 10 to the negative 7th molar of water does this, and so that means you get 1.0 times 10 to the 7th molar H. You'd also get 1.0 times 10 to the negative 7th molar OH, because you get a 1-to-1 ratio of H to OH when water breaks apart. So these are the molarities, or the concentrations that you get. Now, if you take the concentration of hydrogen ions as 1.0 times 10 to the negative 7th, and you plug that into the pH equation, pH equals negative log of 1.0 times 10 to the negative 7th, you get 7, okay? Which that's where neutral comes from. Because remember, when the H concentration is equal to the OH concentration, then we are neutral. Well, look at what we have here. We have an H concentration and an OH concentration that are what? They are equal to each other. This is equal to that, okay? And that's our neutral pH of 7. It would also be a neutral pOH of 7, okay? Now, if Kw is equal to H times OH, okay, and we can take this H and this OH and multiply them together. Let me actually clean up this screen. Watch this, go to the next page. If Kw is equal to H concentration times the OH concentration, and we just saw that we had a 1.0 times 10 to the negative 7th molar H concentration, and we had a 1.0 times 10 to the negative 7th molar OH concentration, then Kw is equal to 1.0 times 10 to the negative 14th. And that will lead rise to our final equation, which actually is just this equation. This is the equation right there. But we can take this number, 1.0 times 10 to the negative 14th, and we can plug it in to kW. And then all we have to know is either the h or the OH, and we can solve for the missing component. So, example. Okay, so kW equals h times OH. We know that kW has a value of 1.0 times 10 to the negative 14th. We know that the H concentration is 1.0 times 10 to the negative 9th, and we are looking for the variable of the OH concentration. So this is just simple algebra problem. Solve this algebraically. We have this is your x, divide both sides by 1.0 times 10 to the negative 9th. When you do that, you divide this by 1.0 times 10 to the negative 9, and you divide this by 1.0 times 10 to the negative 9. That cancels out, and OH is equal to 1.0 times 10 to the negative 14 divided by 1.0 times 10 to the negative 9, and that's equal to 1.0 times 10 to the negative 5 would be the OH concentration. Okay, now to sum all this up, we can do a graphical organizer because we have four equations that are all basically related to each other. We have the pH is equal to the negative log of the H concentration. We have the pOH is equal to the negative log of the OH concentration. We have the pH plus the pOH is equal to 14, and we have the kW equal to the H concentration times the OH concentration, and we know that kW has a value of 1.0 times 10 to the negative 14. So all these equations are related. You can look at them. They all have the same things in them. They all have pH, H, pOH, or OH. And plus we have the little kW constant. That's all that's in here. So you have pH in this equation and that equation. You have pOH in this equation and that equation. You have H in this equation and this equation. You have OH in this equation and this equation. So they're all related. And you can go from H to OH, or you can go from H to pH, or you can go from H to pOH, or you can go from kW to pOH. You can convert from any one of these things to any one of the other ones using these four equations as your guide. And so, for example, if we have the pH, then we can go to the pOH. We can find the pOH if we know the pH. And you would use this equation right here. We'll label these. Let's call this equation 1, equation 2, equation 3, and equation 4. If I want to go from the pH to the pOH, if I know the pH and I want to know the pOH, then I can just use equation 3 to do that. Okay. I can also, if I know the pOH and I want to go back to the pH, I can use equation 3. Okay. If I know the pH, I can actually calculate the H concentration. And we haven't done that. We'll do that. We can calculate the H concentration as well. Or if I have the H concentration, I can calculate the pH. And that would be using equation number 1 to do that. If I know pH, I can find H. Or if I know H, I can find pH. And likewise over here, I can do the same thing with pOH. If I know the pOH, I can calculate the OH concentration. Or if I know OH, I can calculate the pH concentration. In that case, I would use equation number 2 to do that. If I know pOH, I can find OH, or if I know OH, I can find pOH. Normally we have OH and we go find pOH, but I can do the reverse. And if I know the H concentration, I can find the OH, or if I know OH, I can find the H concentration. I can go back and forth between these two. I should put that in brackets. And if I want to do that, I'm going to use equation number 4. So we have this circle that we can run through. We can convert pH to pOH, then we can convert pOH to OH. I convert OH to H, and I can go back to pH. We have this circle that we can run through all these equations, okay, using these four equations. Let me do an example of converting the pH into the H concentration, just so you can see that, because you'll see that on some practice, and that will be the last one we do. So what is the H concentration if the pH is equal to 4.4? And so the equation that has both H and pH in it is that pH equation. pH is equal to negative log of the H concentration. Okay. In this case, we've been given the pH, so we're going to plug right in here pH, which is 4.4. So 4.4 equals negative log of the H concentration. Okay. Now the math here, depending on what math class you're currently taking, you might know what to do here. You may not know what to do here. And so I'm just going to walk you through it real quick. And I'm going to use a terminology that they may not use in math class. I don't know what the term they use in math class is, but it's what I learned when I was growing up. And so I'm just going to isolate H+. And so I need to get rid of this negative. So I'm going to divide both sides by a -1, basically. If I divide by a -1, then this 4.4 becomes negative 4.4. And the negative logarithm becomes the positive logarithm of the H concentration. Now, here's something that you can't do. So students who don't know how to do logs, what they'll do is they say, okay, I have the log times the H, so I'm going to divide both sides by the log. That's not how logs work. And so what you're going to do, what I called this growing up, is I called it taking the anti-log. So if I take the anti-log of the log, okay, the anti-log of the log, it basically turns into 1. So if I do the anti-log of the log, then this all goes away, and I get H+. So whatever I do to the right side, I have to do to the left side. So I have to take the anti-log of negative 4.4. Okay. Now, on your calculator and in practicality and mathematics, the anti-log is 10 to the x. Okay. So what the anti-log of negative 4.4 is, it is 10 raised to the power of negative 4.4. That's what the anti-log is on your calculator. So if you find the log button probably close by, maybe as a second function, it's going to show up as a 10 to the x. That's the button you're going to push to do the anti-log. So the H concentration is equal to the 10 to the raised to the power of the negative pH. That's what you end up getting there. So when I take the anti-log of negative 4.4, or I take 10 to the raised negative 4.4 power, I get this number in my calculator, which I'll convert to scientific notation. So that's going to be 3.98 times 10 to the negative fourth. Negative fifth. Okay, and that's concentration. So remember, what's the unit of concentration? That's going to be molarity. And so that is how you work that calculation. Okay, you can rewatch that if you want to, if you need to catch it a little bit slower, but that's how you work that way. And so if we go back here to the slide, then you can go any direction. You can go pH to pOH, you can go pOH back to pH, you can go H to OH and vice versa, you can go pH to H and vice versa, you can go pOH to OH and vice versa. Okay, that's it.